All right, Mr. Buckle here with example 2 from 4.3 on solving systems with elimination. We have another set of systems here, or a set of systems in which both of these equations are in standard form, and that's kind of the cue for when elimination is nice, is when both of the equations are in the same form, and its standard form generally is the easiest way to do that, because we have x plus y term equals a number, x plus y term equals a number. These things are nicely lined up. X terms, y terms, equal signs, and then just constant terms on the other side. What is not nice about this one that we're given here is that none of these variables have opposite coefficients or opposite numbers in front of them. So when we add these equations together, neither variable is going to go away because there are no opposites here. X plus 2x is not 0. 3y plus 2y is not 0, so that's a problem. So we have to manipulate one of these equations to make that the case. So if I look at this, one of these is going to be easier than the other, so I'm going to look at this x right here. I want the number -2 to be in front of this x, because -2x's plus 2x's is 0. And that's going to be easier than trying to manipulate these y's. So I want this x to have a -2 in front of it. So what I'm going to do is I'm going to multiply this entire equation by -2. Because I can't just change this x term. I got to change the whole equation with it. Otherwise, I'm going to change the problem. I can't do that. So to maintain the equality of this equation, I have to multiply every single term here by -2. And I'm picking -2 because that's the opposite of this +2. So I'm going to do that. And when I do that, I get this equation here. So this equation is the multiplication that has occurred after I multiply this x plus 3y equals 7 by -2. -2 times x is -2x. -2 times +3y is -6y. -2 times a +7 is a -14. So this equation, x plus 3y equals 7, has been changed to this. It's exactly the same equation. I've just multiplied it by -2. So nothing has changed with the value or equality of the equation. I've just changed the numbers in there. So the x and y will stay the same. Then the bottom equation, I'm just going to leave as is. So this equation just stays as is. I didn't do anything with that one. So here's the system now. And now we have x terms that are opposites. So -2x plus 2x is 0. And then we can do -6y plus 2y, bring down our equal signs, and then do -14 plus 6. So we do that, and we get -4y equals -8. The -4y comes from -6y plus 2y. It's -4y. Notice the x terms are gone. Why? Because -2x plus 2x is 0. There's nothing left. We've eliminated the x's. That's what we wanted to do. Equal sign comes down, and -14 plus 6 is -8. So -4y equals -8. Divide both sides by -4, and you get y equals a +2. We're not done. We got to find out what x is. So we're going to take this y value that is 2 now, we know that, and plug it into one of the y's up here. Which one? It doesn't matter because they're the same y. So I'm going to pick the bottom equation. I'm going to pick this 2x plus 2y equals 6. And I'm going to rewrite that here. 2x plus 2 times 2. This y has become 2 because y is 2. That equals 6. Now I'll just do some basic algebra to find out what x is. 2 times 2 is 4. So 2x plus 4 times 4 equals 6. Subtract 4 on both sides, and you get 2x equals 2. Because 6 minus 4, if I subtract 4, because it's plus 4, I get 2. If 2x equals 2, 2 times x equals 2, divide both sides by 2, and you get x equals 1. So the solution to this system is x equals 1 and y equals